So series and application. Now, as I've mentioned sometimes before, mathematics, if you like, is the science of patterns. And what we do a lot of time is look for patterns. And that's how we can solve different problems, by discovering these patterns. Some definitions to start off with. There we go. You'll hear the word sequence sometimes used instead of series, or progression. There's sort of old terminology that's not in the syllabus now, but some of us old people still use the old words. And so if you hear me talk about an arithmetic sequence or an arithmetic progression, I'm still talking about the series. I'm just using old terminology. But the technical difference is the sequence and progression is just a set of numbers that follow a pattern, whereas a series, it's still the same set of numbers. But the difference is, instead of putting a comma between each term, I put a plus sign. And so the series technically is all those terms added together. So that's the technical difference between the two things. A sequence is just a list of numbers, whereas a series is the sum of those numbers. Yeah, very creatively we came up with the letter A to use for the first term. Some genius thought of that, not sure who. Term with a subscript, which particular term we're talking about. So technically A could also be term 1. And then the actual series itself, so the sum of all the terms, we do S with a subscript, however many terms we're talking about. So an example here would be a formula for a particular pattern. It's n squared plus 2. It's really not rocket science, it's basic substitution really. I want to find the fifth term in this particular pattern. Oh, well, I'll sub in 5 for n, 27. I want to find out, is 42 in this particular number pattern? Well, then I solve the equation. Well, the formula was n squared plus 2. Is this possible to be 42? Now, of course, the answer is yes, it's possible. However, if it's a term, a number of terms, it needs to be a whole number. You can't have, oh, that's the square root of 40th term. Right? So because I don't know the square root of 40 exactly, I can't make n an integer. So no, 42 is not in this pattern. Okay. We're going to look at two specific types of series. Arithmetic and geometric. Okay? Arithmetic, the sequence of numbers follows a pattern, and it's a simple pattern. It's just by adding the same amount each time. So adding a constant number, and that constant number we just call the difference, because it's going to be the difference between the two terms, and we use the symbol D. So if I wanted to work out what the common difference is, I could take away the first term from the second term. I could take away the second term from the third term. In fact, I could pick any term I like and take it away from the next term. So I could create a little formula, I suppose, term n minus 1. We probably don't use that. I mean, it becomes more intuitive where we go, oh, I'm just going to take away. You don't actually need consecutive terms either. Because if I had, say, the first term and the third term, then I know it'll be two common differences between them. And I could work it out that way. So let's come up with a general formula. Term 1 we said is A. Term 2 then would be A, and I'll add on a common difference. Term 3, add on another common difference. So I've got 2D, and hopefully we can see that we generalise this quite easily. We've always got one less difference than whichever term it is we're trying to find. So if I want to find term n, it's A plus n minus 1D. All right, so I know term 3 is 9, term 7 is 21. I want to know what that general term is. What's the formula for this number pattern? So term 3 is 9. So I know A plus 2D is 9. Term 7 is 21, A plus 6D is 21. It's just simultaneous equations now. Let's work out what A is. Let's work out what D is. I can then create a formula. What do we get? D turns out to be 3. Sub that back in. By a coincidence, A is 3 as well. So in my general term, it'll be 3 plus n minus 1 lots of 3. I mean, that's a formula, but we can make that a lot neater. Let's expand out, tie it up. Simply multiples of 3. So this number pattern is multiples of 3. And when we look back at the terms, that makes sense. Oh, yeah, term 3, 3 3s are 9. Term 7, no, 7 3s are 21. That is indeed our pattern here. So what would term 100 be? Oh, well, I now know the pattern. It'll be 3 lots of 100, 300. Which term will be the first one bigger than 500? So I get my general term and I say, well, when is my general term greater than 500? And that's the inequality that I want to solve. So when is 3n greater than 500? 500 over 3. Now obviously there's lots of numbers that are bigger than 500 over 3. We just want the first one. And it has to be a whole number. So the first whole number that's bigger than 500 on 3, 167. Because 503 turns out to be 166 and how many thirds? 2/3? So 167 is the first whole number bigger. And that particular term turns out to be 501. Okay, now that is from our Cambridge.